Hello, this is Dr. Polig, and we are going to work right now, practice problem number 1 on page 422. This is module 12, geometric optics, and problem number 1. An object is placed 3.5 centimeters away from a concave spherical mirror with a radius of curvature of 5 centimeters. The problem is to draw the ray tracing or diagram which illustrates the image, which shows the object, illustrates the image, and determine if it's a real or virtual image, upright or inverted, and magnified or reduced. Okay, when you have a problem like this, the first thing to do is to draw the optical axis. It's really the center line of the whole problem. So my paper, although you can't see it, is a ruled paper marked off, and it's like graph paper. So I would encourage you to use something like this. Always make your drawings scaled drawings. Using graph paper makes it very, very nice to actually do that. So I'm going to draw the optical axis. As such. Okay. Now I'm going to draw the concave mirror. Whenever you do draw a concave mirror or a lens, draw it as a vertical line. And so this vertical line, like that, that is my mirror. This is my concave mirror. So we're going to, it's drawn as a flat mirror, but really it's concave mirror. And to help me think of it as concave, I'm just going to draw a little bit of concaveness to it. It will open to the left, concave mirror like that. Okay, but really the rays will reflect from the vertical line. Okay, and I will demonstrate this. Okay, problem says that the radius is, whoops, let me come back. There we go. The radius is 5 centimeters. That's the radius. The focal length then would be half of that. The focal length is defined as a radius for a mirror, the radius divided by 2, so that will be 2.5 centimeters. So I'm going to come to my drawing. I come to the center of my mirror right on the optical axis, and I count over 1, 2, 3, 4, 5. That is my radius. That's my radius right there. I come over half that distance, which is right here. That is my focal length. Put a F there, little f for focal length. The object, the problem says the object is placed 3.5 centimeters in front of the mirror. So this is the object. That's where the object is located. And what we're going to use for the object is actually an arrow with a arrowhead on it, just like that. That is my object. Okay. So now we've drawn the problem. These problem ray tracing consists of drawing 3 rays. Ray number 1 is what we call parallel in. Okay, what that means is the ray starts from the left here, and it comes in parallel to the optical axis, and it will then hit the mirror and then reflect back through the focal length. So these rays, these 3 rays we're going to draw, they all need to pass through the tip of the object. So the ray number 1 will come parallel in to the optical axis. like that. That's ray number 1. Notice it's parallel in. It hits the mirror, and then it will reflect. Reflect where? Well, a parallel ray in reflects through the focal length right here. So it will reflect through the focal length, and that is ray number 1. The ray comes in this way, hits the mirror, reflects through, and comes right through the focal length and out. So that's ray number 1. Ray number 2. Ray number 2 is what we call parallel out. Parallel out. In order to get a ray parallel out, it has to pass through the focal point, hit the mirror, and then it will bounce parallel out. Does that make sense? That is parallel to the optical axis. Remember now, this is the optical axis. Everything is in reference to the optical axis. So I'm going to draw ray number 2. It's, again, it has to pass through the tip of the object. Ray number 2 passes through the tip of the object through the focal point. It hits the mirror. Whoops. It hits the mirror right there. And then it comes parallel. This is ray number 2. Then it comes parallel out. I'm trying to make that parallel out. That's ray number 2. Okay, so ray number 2 hits the tip of the object, passes through the focal length, hits the mirror, and bounces out in a such that this ray here is parallel to the optical axis. Parallel out, that's what we mean. Okay, ray number 3. Ray number 3 passes through the radius. Okay, so here's the radius. So imagine a ray that comes through the radius, hits the tip of the object, hits the mirror, bounces back through. Exactly. A ray passing through the radius will hit the mirror and reflect back on itself. Okay, so let's start. This ray starts around here, goes through the radius, goes through the tip of, there's a tip of the object right there, hits the mirror. Now it reflects back on itself and will pass straight like that. That's ray number 3. Now notice all of these rays more or less should come to a focal point, and they're a little bit off. I think my ray number 2 dived down a little bit. I think ray number 2, I didn't quite make it parallel out. It should have come around like that. In any case, you can see that all these rays are coming to a point right here. This is where the image will be. The image will be where these 3 rays join, right there. So this would be the image right there, I for image. Okay, so the object is over here, but the image is here. So the 3 questions that we are to answer is the image real, or is it a virtual image? And this image you can put on you could put this image onto a piece of paper, onto a wall. Another way to think about it is all of these rays are real rays. Notice none of these are virtual rays. So this is a real image. The next thing we have to decide, is it upright or is it inverted? Well, it's upside down, so it is inverted. Next thing we look at, is it magnified or is it reduced? And just by looking at the drawing, we can see that it's been magnified. So this is what your problem should look like. Something like this. Notice it's not a perfect drawing. Part of the problem I'm having is I'm using this software which jiggles my lines a little bit, and it's hard to use a straight edge. If I would do this on a real piece of paper with a real ruler, I should be able to get closer than just having this vague intersection point right here, over there. But hopefully you get the idea. The main thing is to make a good drawing, make a scale drawing, make it to scale, or use a scaling that's that fits on your piece of paper. Make a nice big drawing. Use up a full piece of paper if you can, and you can tell it's a real image. It's a inverted image and it's magnified. Okay, that's problem number 1.